Hey guys, just a brief introduction before we get started. This will be our first lecture. This will cover Module 1, Introduction to Networking. And so I just wanted to real quickly get us started here. We're not going to spend a lot of time lecturing. Ideally, your responsibility is to read the material in your textbook, and the things that you want to concentrate on are the slides that we're going to be looking at for the lecture. I'm going to go through these and kind of outline them, try to hit the high points. I'm not going to spend a lot of time doing this because, frankly, I don't think you learn as well by listening as that you do by doing. So, most of our class time will be spent in hands-on work. We're going to try to get 2 labs every class that we have, and that should get us finished early. So we should have time if you have to make up work for absences, or if you need to hit something else again because we didn't understand it, then that will take us where we need to go. So we're going to try to do 2 labs per class, and I'm just going to, during these lectures, sort of hit the high points as far as the content goes. I will be going through the slides and also occasionally jumping back and forth to the textbook. Make sure that you click on the link, read your textbook, the things that you're expected to read. I'm going to tell you right now, TLDR is not a good excuse. That will get you a bad grade. So please do me a favor, read the material. I'll try not to make the lectures tedious, but you absolutely need to get the material. This is a self-guided class for the most part. The only in-class work we're going to do is lab work and occasionally answer questions. We might have a quiz in class, possibly, but for the most part, your actual schoolwork, quizzes, etc., will be online. So, having said that, let's go ahead and get started. All right, guys, so here we are. We're looking at the slides for our first lecture. Module 1, Introduction to Networking, is the title of the module, and I'm just going to kind of go through this. The icebreaker that we're going to do, just to kind of get the class started, this we will do in class. Basically what we'll do is you're going to break up into teams. Most of the classwork in this class, when you're actually in the classroom itself, will be done in teams. We do a lot of work in teams because, frankly, it's just easier and more logistically sound way to do things. So you're going to pair up and you're going to talk to each other, and then you're going to introduce each other to the classroom. So think about a story, basically connecting your personal experiences to the topics that are relevant to this course. Maybe you could tell how much experience you've had doing network or IT work, or some entertaining anecdote that you've discovered while doing this kind of work. So that's going to be our first activity during class. Then we'll move on to the lab. Okay, these are the objectives, and here's a good way to tell how you're doing in this class as far as what you're learning. By the end of each module, you should be able to look at these module objectives and just know the material. For example, by the end of the module, you should be able to distinguish between peer-to-peer and client-server networks. Those are 2 types of networks we'll learn about, and you should immediately know the difference. Types of applications and protocols used on a network. We're going to be looking at the different, particularly protocols. We're going to focus on different, like FTP, File Transfer Protocol, HTTP, Hypertext Transfer Protocol. Those different sets of rules that we use to build a network, those are the kinds of things that we're going to be looking at. Describing various networking hardware devices and most common physical topologies. You need to know the difference between a physical and the different types of topologies available. We'll talk about that in just a second. But also the various hardware. You need to know the difference between a router and a switch. You need to know the difference between Cat5 cable and Cat6. You need to know basically the hardware that's going to be used to build a network. Also, the 7 layers of the OSI model. We will go into great detail on the OSI model and the various applications and what layer they operate in. So we will go into detail on that. Safety practices, we will actually talk quite a bit about safety practices, things that you would expect when working in an ordinary office environment, as well as things specific to computers having to do with voltage, having to do with sharp objects, having to do with fire safety, how to pick the right fire extinguisher, that sort of thing. Also, how to protect the computer equipment. We'll talk a little bit about static discharge prevention, things like that. And then finally, describe a 7-step troubleshooting model for troubleshooting network problems. And there are 7 distinct steps. It's nice to break something like that into distinct steps so that you can say, well, I've done this, I've done this, I've done this. And they're all documentable. That's going to be the last step in any process, particularly this one, is you document, because there's no point in solving a problem if you just have to resolve it 6 months later when you've forgotten what you did. So those objectives are what we're trying to learn for this section. So at the end of the section, we're going to go back and look at these again, and you should say, hey, well, yeah, I know that, I know that, I know that. So without further ado, let's get started. First of all, topology. These are the vocabulary words that you're going to need, and you need to know these. You will see them on the quizzes, and you'll see them on the tests. So vocabulary is important. You need to be able to know what you're talking about and to use the right terminology so that other professionals in your field will know what you're talking about. Topology is basically a description of how all the parts work together. It is a description of how something is put together and how it works. The physical topology describes the different pieces and how they're connected. For example, if there's a router and it has a network cable that leads to a switch, and then from that switch there are 4 different computers and a networked printer and a SAN, then that's the physical topology. The components and how they are connected, the cables, whether there's a wireless bridge, that sort of thing. That's the physical topology. Logical topology refers to how the software controls access, whether it's a star pattern, whether it's a chain, whether it's a peer-to-peer, whatever. It's how the software controls it. So think physical is hardware, which that makes sense, and that logical is software. Basically, this is how the network traffic is routed. Also, how many users and how the users log in. That's another important. Network operating system, NOS. Basically, this is required only in client-server models because in a peer-to-peer network, your NOS is going to be just your regular operating system for your computer, which in this case, for 99% of the class is going to be Windows. We're going to be using Windows Server, and for the most part, that is our network operating system. We will, however, look at Red Hat, Ubuntu, and some other Linux versions. We're probably not going to look at Apple a great deal as far as network operating systems go, just frankly because we don't have the access to it. So our main focus is going to be on Windows networks and on Linux/Unix networks. Peer-to-peer is the first type of network that we see, and basically, as the title says, it is peer-to-peer. One computer to another computer to another computer. Basically, you're just sharing resources. You share a folder on one computer and the other computers on the network can hit it. Then that's a peer-to-peer networking solution. The OS, the operating system of each computer, is responsible for controlling access. There is no centralized control. There's no domain controller, anything like that. Basically, it's just you sharing folders. If you share a printer out on your computer and other people can use it, then those are peer-to-peer network pieces. Computers and printers and whatnot are called nodes or hosts. They form a logical group. Basically, each computer is responsible for its own safety and its own administration. Think of this as a work group. If you're familiar with the way Windows networks, there are 2 things you can have. You can have a domain, which is involving a server. That would be a client-server model. It involves a server controlling access to files, controlling who has access to network resources, and then a work group, which is basically a peer-to-peer network. You're just sharing folders on your computer and other people share folders on their computers. The advantage for peer-to-peer is it's simple. Basically, you right-click on a folder and go to security, share it to the other computers, and then as long as they have the same workgroup name, it's easy. You don't have to buy a server. You don't have to buy server operating system or hardware, so it's a lot less expensive. The disadvantage is it's not scalable. You cannot It can't be too big, because when it gets too big, basically you can't find things on the network. It's not secure at all, because once you're opening up and sharing folders and files, basically you're just asking for somebody to take your work or move a folder or delete a folder that you didn't really want deleted. So it's not practical for large corporations. It's not practical for big locations or big installations. No computer has more authority than the other. Each computer controls its own resources. At the same time, if you don't share something, it's not available. And that goes for scanners, network printers, storage devices like SANs, shared drives, things of that nature. On the other hand, the client-server model involves some kind of a network operating system and a centralized directory database. In this case, the centralized directory database is the Active Domain Services from Windows. A Windows domain is a logical group that a Windows server can control. Like I said, that's going to be 90% of what we look at, because most business offices, that's what you're dealing with, either Windows server or some flavor of Linux. And so we will look at both of those. Active Directory is a centralized directory database. It contains all the user account informations and the securities and the policies, a lot of policy information. So when you want to access a domain that you're a member of, then you log in with your username and password into the server, and the server says, okay, you're not an administrator, you're a user, so you only have access to these things and these things and these things. So basically, the domain controller uses the Active Directory database to decide who can access the network and what permissions they have. Computer making a request is called a client, and it makes requests to the main central computer called a server. This is not a mainframe. We will not look at mainframes in this class. Very few institutions use a mainframe computer anymore. Basically, the difference between client server and a mainframe is that the mainframe supplies not only permissions to access, but it supplies all the computing power. A client on a mainframe network is just a dumb client. It has minimal processing power, minimal RAM, and all the work is done on the server. Back in the day, when computer work was not as resource intensive, that was okay. You could afford to do that. Nowadays, computers are just too busy. They have to have their own clients. They call them thick clients. That means they have, I love that word. That means they have their own RAM, their own processors, and they do their own work. All you're doing from the server is getting permission to use the network and getting permission to use the files that are stored there. So a thin client works on a mainframe. A thin client has no real processing power, no real RAM. It just connects to a mainframe. That is probably the extent of what we'll go into as far as what a mainframe is. We're looking at client-server networks. The clients are a lot more useful. Okay, so basically, if you look at the image here, this would be, we were talking about topology a while ago, physical and, you know what, I forgot that word. I always do that, and that bothers me to no end. Logical. Thank you. Logical topology. In this picture, if you'll look, essentially what we have here is the server in the middle, and then we have radiating out from the server, we have different connections to a shared printer, to different clients, to different peripherals like scanners and local printers here. And then we have this database here, all these cylinders. Anytime you're looking at a network diagram, a cylinder like that is a database. In this case, it's the Active Directory database. So the server gets a request from a client. Let's say this Chromebook up here wants to log into the network, so it sends a request to the server and says, I want to log in. The server says, wait a minute, are you allowed to? And then it looks into this database and says, okay, this person wants to log in, his username is blah, password is blah. Oh, so he's here, and he's an administrator, so he's allowed to log in and he has access to these things. It sends the reply back, okay, Chromebook, you're allowed to log in. It allows access for the Chromebook onto these onto the resources of the network, and sure enough, the Chromebook says I want to print, and the server says, do you have permission to print? Checks the Active Directory. Yes, you're a printer operator, so it sends, the Chromebook sends a print job, server sends it to the printer, and the printing is accomplished. And the person gets up and walks over to the printer and gets it. Now, this logically is what's called a star network. You'll notice it radiates out from a central point. That means each of the nodes here has a direct connection to the server. And so that's a star. Now, does it have to look physically like this? Is the physical topology a star? No, it is not. In fact, I almost guarantee you it'd be more like a server in a server room down somewhere on the first floor of a building, and then all over the building there are network cables running to the various nodes. So it would not look like a star. It doesn't have to be laid out like this. That is the difference between the physical topology and the logical topology. The logical topology tells how the network is routed. The physical topology is more of a picture of what it looks like. And so it's important that we know that. Network operating system, in this case, is going to be Windows Server. It manages client data. It ensures that the users are authorized. That means you have an active and an accurate or an active password and username. It controls file access. That means that administrators have access to more things than regular users do. It restricts user network access. If you're not an administrator, you may not be able to access some different parts of the network. It dictates computer communication rules. It allows communication through maybe a firewall, things like that. And it supplies applications and data files to the client. So the server may have applications running on it that the client can't run on their own. And so in order to use that program, you have to log into the server and access it via that. Also, data files, the file server on that network may protect certain files and not let just everybody have access to those. Servers that have a network operating system installed usually require a lot more memory because you have requests coming from everywhere, a lot more processing power because you have possibly applications running on it, and those require a lot of processing because in addition to running the application, the network operating system still has to monitor and maintain the network. So you can imagine that servers require usually a lot of processing and memory. And then particularly if you're storing files, you have to have considerable storage capacity. Also, they may be equipped with special hardware like multiple network cards. So you have one network card that talks to the internet, and then you have another network card that controls the interior network, and then between those two, maybe there's a firewall installed. So there are often differences in hardware. Now, important thing to know, and this will probably be on the test, does a computer that is a server have to look like a server specifically? The answer to that is no. A computer server, a network server, can be on a laptop. It can be a regular computer. It can be anything that will run the operating system. The server itself is not necessarily a specific hardware configuration. The server itself is more likely to be the software running on it. Any one of these desktop computers will run Windows Server for the most part. You could set them up as a server. Now, would they have enough memory and enough processing power? Maybe not. But they would be able to run it, and they could operate as a server. So don't get the idea that a server has to be a giant computer somewhere in a rack that's got dual processors and 32 or 64 gigabytes of RAM and hooked up to a SATA drive or to a RAID 5 drive of some kind. No, a server can be anything. It can be any kind of hardware as long as it's running the server operating system. So that's the difference. So network services, these are the resources that a network makes available to its user. That can be network traffic, that can be access to files, that can be access to applications. Those are the different network services. In a client-server application, a client computer requests data or services through the server. So your computer, your workstation is the client. You make requests to the server. You're requesting to use the network. You're requesting security to protect your files. You're requesting access to access the server's files or to access materials or resources on someone else's computer. Basically, you make a request to the server, and then the server checks your permission through Active Directory, and then it allows you or doesn't allow you to connect. Basically depends on whichever one is applied there. A web server is a type of client-server connection that you should already be familiar with. A web server is a server that specifically runs some sort of web service application. It can be something like Apache, or it can be Windows IIS. It can be, and I think Apple has a server. I'm not exactly sure. I'm not a very big Apple fan. I'm more Linux and Windows. But web servers basically allow clients to request web pages. Web pages are HTML, hypertext markup language documents, and other resources like videos or audio, podcasts, things like that. A web server provides the storage and the processing to make those work and make them available for client requests. So if you're on your workstation, you're on your laptop, you're on your phone or whatever, and you type in a web address, basically then what will happen is your client, that device that you're on, will make a request to the web server, and the web server will look and say, hey, I've got that information and it's available and you have permission to access it. So it sends back the web page to you, or the whatever kind of data that you're trying to access, whether it be video data or whatever. So a web server is a server client connection between you and the web page, basically. And so the most common use is probably the internet. You're sitting at home connected to the internet, and the internet is just basically a huge collection of networks connected together. And somewhere out there, there's a web server, and you want to look at a page, so you send the request to an IP address, which we'll talk about later, and then assuming that the web server has that information, it will send it back to you. Different protocols. Protocols are basically the rules. Protocols are the way that communication occurs between networked devices. TCP and IP are the two primary protocols of the internet. Transfer Control Protocol basically packages the data, and IP, or Internet Protocol, routes the data. That's why we have IP addresses. So we'll look at both of those in detail a little bit later on. Some different client-server applications. Web service, we just talked about what a web server is. Email services. To send email, you use Simple Mail Transfer Protocol, SMTP. To receive mail, you have the old style POP3, which is plain old Post Office 3, or IMAP, and so that's another protocol. DNS services. Computers don't read English nearly as well as they read numbers, so domain name service basically allows you to send Microsoft.com as a request. Then the web server goes to a DNS server and says, hey, Microsoft.com, I don't know what that means. The DNS server says, well, it means that the request needs to go to 10.10.75.120, gives it the IP address, and then the web server can send Microsoft's web server a request. FTP stands for File Transfer Protocol. For the most part, this one's been deprecated. There are a lot better ways to send files than FTP, but a lot of people, particularly web designers, web programmers, still use FTP services. Database services, we talked about Active Directory. There are other databases like SQL and Remote Access Service. This allows you to use the RDP to log into someone else's desktop, and we will actually practice that quite a little bit later on. This is a mail service. This is basically how email is sent. So the sender uses the Simple Mail Transfer Protocol to send an email message to a mail server. That mail server uses SMTP to send out through the internet to the receiver's email server. The receiver's email server gets it, and it uses a protocol called plain old post office, or IMAP, to send the email to the receiver. And so that is how email is sent. You need to go and make sure you know the parts, particularly of this, because this is one of the more common network processes. You will need to know that. All right, knowledge check. Which of these protocols could not be used to access a server? Telnet, remote desktop, TLS, or secure socket? I'm assuming that you've read the material, so I'm going to ask this question and let you tell me. It should be covered in the chapter, the first chapter. These are all fairly common protocols, and then we'll go ahead and answer it. This is basically just to tell you if you got the information that you need. And the answer is TLS. That's Transport Layer Security. This is an encryption service, and what it does is it encrypts the data. It encrypts things like HTTP, but it does not provide transport. It doesn't provide access to remote computers. It just encrypts whatever's being sent. So you would actually be sending over Internet Protocol, but you would use TLS in order to encrypt the data so that nobody else could break into it. Network hardware, we're not going to go into too much detail on that. I'm going to let you read this part for the most part, but if you look at this model network here, you'll know there are 5 computers. That would be a Windows Server, Windows 10, a Chromebook, a Mac, and an Ubuntu, all connected to a switch. Also some other peripherals like a scanner and a networked printer, and then this local printer could also be shared. Basically, we're looking at another network that is a star, has star topology. That, by the way, is logical topology, not physical. This would not look like this if you were to look at it in the building. If you were to go to an office building and look at a star network, it would not be all nicely laid out in a star pattern. It would be a lot of cables running in big bundles. And basically every device is plugged into its own little cable, except for maybe the local printer here or the scanner. But regardless, every node is connected to the switch by its own network cable. And so they all run back, one individual run runs back to the switch. So that's what a star network in logical topology looks like. It would not look like this physically. A LAN, local area network, is a small space. Now, that's relative because LANs can cover a 70-story skyscraper. That's not a small space, but compared to the internet at large or compared to an intercontinental network, it is pretty small. So local area network generally is contained in a single building. A switch receives incoming data from its ports and redirects it to another port or multiple ports. Now, there are managed switches and there are unmanaged switches, and we'll look at the difference a little bit later. But switches tend to broadcast data and send out packets all over the place. I mean, they basically send out, a managed switch can kind of control where it sends the data, but for the most part it does not, it's not specific to a single computer. It doesn't take in information on one port and send it out to another port only. It can send it out to a whole range of ports or a whole range of network plugs, and when that happens, then the one with the correct IP address is the only one that will respond. Physical topology, that is actually not correct. That is logical topology. In this case, that should be logical because star topology is not physical. The network wouldn't look like that in the building. I need to fix that. All devices connect to a single device, usually a switch or some kind of router or something that basically allows traffic to connect to all the different nodes. A network interface card is the card that goes in the back of your computer that allows you to plug in. It's also called a network adapter. Now, a LAN may have multiple switches. It will usually only have one router. It can have subnets with multiple routers, but for the most part, a local area network is going to have one router pardon me, and it will connect maybe to multiple switches, and then those multiple switches will connect to multiple nodes, clients, computers, uh, printers, and things like that. So the main lines that come back to the router from the switches are the backbones. That's the central or the main line of the network that connects to the router, and it connects the different sections of network together, and then the network cables that connect the nodes or the computers to each switch are just network cables. So the backbone, usually the backbone will be fiber optics. It won't be copper, something like that. If it's any kind of large network at all, then the backbone will usually be a fiber link between switches. The switches will have fiber connections for their connection to other switches, but then they'll have copper regular network plugs for the regular nodes that connect to them. So what you'd have here is a switch, and it's got 4 clients, and then you'd have you'd have copper going to the clients, but then you might have fiber going to this next switch. It's got 3 clients that would be connected with copper, and then maybe another fiber, and that would connect to, say, 3 more clients here. So this local area network, and then maybe you'd have another fiber run off to the router if these are switches, or maybe one of these would be a router. What matters is that you've got high-speed connection between the switches. That cuts down a lot on your network traffic. The router is a device that manages the traffic between 2 networks, just like a switch manages the traffic between 2 clients. It can help form the best path for traffic. It can also do things like port forwarding. If you've ever played a game and you have a server, like for a Minecraft server or something, then you should know about port forwarding. When you want someone to be able to play a game on your computer with you, then you have to set up a port forward so that you open a hole in your firewall, let your router route traffic to that specific port that the game uses. Routers can be used in small home networks and connect the homeland to the internet. You need to know what a SOHO is, small office, home office network. Basically, that's what most people have in their houses. You might have a couple of computers and a networked printer, maybe a smart TV, things like that, and then connecting to one router. And so the router controls all the traffic, usually also acts as a DHCP server, usually also acts as a firewall and protects the network. Industrial grade routers, on the other hand, will have multiple network ports, and you can connect multiple, like we talked about a while ago, you can connect multiple networks, multiple sections, multiple backbones to the router via the different ports. The difference between a router and a switch. This question will be on the test. A router is a gateway between networks. It connects local networks or not so local networks. A switch, on the other hand, only works on one network. It's going to have one. It's gonna just have clients that connect to each other via its ports. It's not going to usually have any control over routing or anything like that. It's not going to be able to manage. Hey, I need to switch IP addresses, and we're going to go to a subnet here. So that's not the sort of thing that a switch can do. A switch is basically just a straight connection, where a router connects multiple gateways. It can connect different IP schemes, and it can control which ports what data gets sent to. So we'll look at the difference between a switch and a router more in detail. And so basically what we have here is a picture of the internet. So we've got the internet. This is a home router, and these would be the computers you have at your house connected to a switch. The switch has a little backbone that connects it to the router, and then the router connects to the internet. The router handles DHCP for the home network, and it also handles things like port forwarding and firewall duties for the traffic coming in from the internet. So let's say you wanted to get an email to someone on another network down here. You would write your email on your computer. It would go to the switch. It would go to the router. The router would find the address of the email server that you wanted to send it to. It sends the information out of the internet, and from the internet it would come into this network router here, and the email server is located out here. It would send it to this, which when they say a combo device, basically that's a combination router and switch. Most people, like if you've ever seen one of these little Linksys routers, a little blue router that has 4 network plugs and an internet incoming switch, that's basically what a combo device is. It also usually has a wireless antenna. So that information comes in from the internet, hits this router, goes to the right computer, and there your email has been delivered. So that's basically what the difference here is this router is just a router and it has its own switch. This one is like a Linksys or something like that that's got a wireless router, it's got a wired router, and it also has usually a 4-port switch. WAN, Wide Area Network, is a group of LANs. You might have a really big building and it's got the marketing's on one floor and production's on one floor and administration's on a floor. Each of those separate business groups would have their own network, and then those networks would be connected to each other through a WAN, a Wide Area Network. A MAN, Metropolitan Area Network, basically it's a city. It's a city-wide network. So you've got a building on Main Street, and you've got a building out on the edge of town. So basically you're connecting LANs. A WAN and a MAN are basically the same thing. It's a matter of scale. Campus Area Network is the same thing. Basically, you're just connecting multiple networks. A PAN, Personal Area Network. Think Bluetooth. If you have a set of Bluetooth headphones and they're connected to your phone, that is a PAN. Personal Area Network is basically, I think Bluetooth really operates within 10 feet. Basically a BAN, same thing, Body Area Network. You're looking at something that will connect headphones to your phone, things like that. Storage Area Network. This is a shared hard drive or a collection. Usually it's a collection of hard drives. You can have multiple terabytes of space on this, and it's usually RAID 5 or RAID, there's usually a RAID level, which we'll look at maybe a little bit later. But a storage area network is just a storage device connected via network. And then a wireless LAN, you should know what that is already. Most of you are familiar with Wi-Fi, and that's what a wireless area network is. MANs and WANs Part 2. I'm going to let you guys look at this. I'm not going to go too much into detail here. Also, now we're finally getting to the 7-layer OSI model. At this point, I'm going to stop because this lecture is going to go on a lot further than what I want it to. So we're going to go ahead and stop here, and then the next time I have one of these videos, the next video will start with the 7-layer model. So I'm going to call this one a day. I'm going to call this one a day, and then we'll move on to the 7-layer OSI model in the next video. So I hope this was helpful to you guys. Remember, if you have questions, I'm in class Thursday nights from 6 to 9, so that is the time to ask questions. I'm going to try to get 2 labs per night done, but I've got a feeling that especially the early ones won't take nearly that long, and so we'll have time. We can go back and look at different things. If you have a question about something, that will be the time. So hope you guys are having a good time in the class. I hope it's beneficial for you, and if you have any questions at all, please let me know. Have a good day.